Audio test. Can you guys hear me? That seems maybe a little bit loud. What about now? Is it better? Cool. All right, we are on. Welcome. Welcome, everybody. This is the third live stream that I've done. The topic for this live stream is actually the same topics we did for the second live stream. I'm essentially doing it twice to try and figure out what works best for my viewers insofar as when the live streams happens. The last one we did was on Thursday evening. And this is obviously Saturday morning for me. I imagine all over the time, looking at our audience from all over the place for the rest of you. In any case, welcome. I'm glad you could join us. My name is Ed, if you don't know who I am. Yeah, I run the blog practicalnetworking.net and this YouTube channel. The topic for today, make sure everything's good. Cool. So I guess let's get right into it. Yeah. So the topic for today is going to be supernetting and aggregation, also known as IP summarization. Those all kind of mean the same thing. What we're going to do is initially start out by defining what they are, then go through 3 illustrations to show you some of the different nuances you might run into when doing aggregation and summarization problems. Then I have an exercise for each of you. We'll have 3 problem sets that you guys can all work through together, essentially applying what it is you just learned in the section prior. And then finally, we're going to solve additional problems using only scratch paper. These problems in here that we're going to work through together are going to be very visual. There's going to be a cool little table and chart that kind of shows us what we're doing. And I want to start there because that's going to show you what conceptually you are doing when you're doing supernetting or summarization. If we understand what we are doing visually, it'll make it much easier later on when we're just doing it with scratch paper. The cool thing is doing it via scratch paper is going to mimic exam situations if you're taking a certification exam or the CCNA or something along those lines. Anytime, if you guys have questions, feel free to just throw them into the chat room. And then I will check in with the chat every once in a while to see how things are going and make sure everybody's kind of keeping up with us. With that said, I guess we can get right into it. I don't really have any announcements channel-wise or anything like that, so let's go straight to it. Cool. So first, let's understand what we are trying to do, what we are trying to solve when we're talking about IP aggregation or supernetting. Now, a prerequisite for this course was going through the Subnetting Mastery video series, which are available at subnetipv4.com. In that video series, we discuss subnetting. but we define subnetting as simply taking a network and dividing it into many sub-networks. So in that series, we start with 9.9.9.0/24. It is a set of 256 IP addresses, and we break that up into smaller networks. We start off by breaking it up into two equal size /28s. The first /25 has 128 addresses, and the second /25 also has 128 addresses. Essentially, these two subnets add up to that /24. This process obviously can continue into 4 equal /26s or 8 equal /27s, each of them with half the number of IP addresses from the size prior. Now, that is subnetting, and hopefully this is all a review for you. If it isn't, definitely check out the Subnetting Mastery video series where I pick this process apart in great detail and show you exactly how all this works. This video, the topic of this video is going to be supernetting. And supernetting is essentially the opposite of subnetting. In supernetting, you take those subnetworks and then you summarize them back into a single network. So subnetting was taking this /24 and breaking it up into smaller networks. Supernetting is the opposite. I would take maybe these 4 /28s and aggregate them into these 2 /27s, or aggregate them into this /26. Now, understand the term supernetting, IP aggregation, and summarization all overlap. They're pretty much interchangeable. And do understand that those terms, and the terms supernetting and subnetting, are relative, meaning in comparison to what else you're talking about. For example, if I take this /26 right here, this /26 is a supernet of these two /27s. But this /26 is also a subnet of this 25. And this 26 is also a subnet of this /24. So the terms supernetting and subnetting are simply relative to what else you're comparing the particular terms to. Cool. So that is the definition of supernetting and subnetting. Next, let's actually work through a particular supernetting problem together. Also, I'm seeing the chat. Welcome from Peru. Welcome from India. Glad you guys can join us. Cool. So our first supernetting problem that we're going to work through together is going to be to summarize these 8 sequential /28s into whatever supernets or whatever summaries we can summarize them into. So if you're familiar with the Subnetting Mastery video series, this cheat sheet should look very familiar. In the Subnet Mastering video series, I told you how to use that cheat sheet to solve any subnetting problem you want. And what I want to draw your attention to right now, since this is a /28, we can use this cheat sheet to determine that the increment for /28s are 16. That means the network ID for every single one of these /28s is going to be an increment of 16. Meaning, this /28 has a network ID of 9.9.9.0, and this /28 has a network ID of 9.9.9.80, and so on. Now, the point of, what we're about to work through is how to summarize these 8 /28s into whatever we can summarize them into. To start, we can summarize them in pairs with each other into the /27 they are next to. I can take these two and summarize them into this 27 and these two into this 27, and continue all the way down, allowing me to summarize all 8 of those /28s into these 4 /27s. That is a perfectly valid summarization of these 28s. But I think I can actually go a step further. If we take these 27s and summarize them into their pairs, we can actually summarize these 4 /27s or these 8 28s into these 2 /26s. This first /26 is going to include all of these IPs, meaning the first 4 /28s, and the second /26 is going to include all of these IPs, meaning the other 4 /28s. But we can actually go a step further. I can summarize them all into a single /25. This 25, 9.9.9.0 /25 includes all of this IP space, which is going to include all 8 of the /28s that I'm trying to summarize. Now, I could actually go a step further. I could summarize them into the /24. Technically, if I said 9.9.9.0/24, that includes all of this IP space, which does include the IP addresses I was trying to summarize. But you'll notice I'm also now including a bunch of IP space that I didn't mean to include in the initial subnets. So while you can go bigger, typically with supernetting, you're trying to summarize into the smallest single network. If not, technically, you could just summarize everything into 0.0.0.0/0, which is the network ID and mask that encompasses the entire IPv4 internet. These 8/28s definitely fit in 0.0.0.0. So, while that would be a correct summary, it isn't the most correct summary. The best answer for summarizing these 8/28s would be this /25 right here, because it is the smallest summary we can use that encompasses all the addresses that we cared about. So that is essentially, excuse me, that is essentially what you're doing with summarization. Let me turn it over to the chat room real quick. Let me know if everything is settling all right, if this is all making sense. We're about to work through 2 more problems, but I just want to kind of check in with the high-level definitions of supernetting and the problem we just solved, and then we'll dive a little bit deeper into how supernetting, into different kind of things you'll run into with supernetting. Cool. Welcome, Rock and Ron from the UK. Welcome, Carlos from Michigan. Cool. Glad this is all making sense. All right. So let's complicate things a little bit further. Let's now take the 8/28s and let's remove a couple of those 28s, these right in here. Now we're going to try and summarize these 2/28s and these 4/28s, so a total of 6/28s. What you'll find is that there's actually 2 possible answers for summarizing this set of /28s. The first one is actually the same answer we just looked at. Technically, this /25 is the single network which encompasses all of the IP space we meant to summarize. But notice this /25 includes IP address space that we didn't mean to summarize in this particular problem. Well, unfortunately, with supernetting, every once in a while, you don't have the option of summarizing exactly to one network. Sometimes, if you're trying to solve for an exact match, you have to supernet into as few networks as possible. In this case, the answer to summarize these 6/28s into their exact matches would be right here. I'd be taking these 2/28s and summarizing them into this /27. And then I'd be taking these 4/28s and summarizing them into this /26. With this right here, I am now matching exactly the IP addresses that I meant to summarize and no more. So this is the difference between summarizing to a single network and summarizing to an exact match. When you summarize to a single network, the benefit is you have a single network which represents everything you meant to represent, but potentially you are identifying IP address space that you didn't mean to. Whereas with an exact match, you're going to match exactly what you're trying to match, of course, but it's not always possible to get to a single network. In this case, we have 2. So that is the difference between summarizing between a single network and an exact match. Now, the question then is, what is the right answer? Well, there isn't always a right answer. At least it's contextual in the sense of it depends what question you're trying to solve. In a certification exam, from the question text itself, you should be able to infer whether they want you to arrive to a single network or whether they want you to specify the IP addresses exactly. in the real world, if you're doing something like routing, maybe you want to add a single route statement to encompass all, in this case, 6 of these /28s. Alternatively, maybe you're doing something like access lists. Well, access lists are a security feature and you want to be a little bit more explicit about those. Maybe if you're doing access lists, it makes more sense for you to add 2 different access list entries, but specify the IP address space you want to permit or deny explicitly without summarizing too generically. So again, both answers could be correct in different situations. So keep that in mind as you're being a network engineer in real life or going through a Cisco certification or other certification exams. Okay, one more example we'll do together, and then it's going to be your turn. So here, we are now again doing 8/28s. Notice these 8/28s are sequential. They're all right next to each other. The first time we did 8 sequential /28s, we were able to summarize them exactly to one subnet. But you'll see this time, it won't be as easy. Every single /28, if we look at this chart, every single /28 has 16 IP addresses. Well, with 8/28s, if we did 8 times 16, that gets you 128 IP addresses. A /25 has 128 IP addresses. So technically, a /25 has enough IP addresses to account for how many IP addresses are in these 8/28s. But here's the problem. A /25 only starts here at 9.9.9.0 through 127, or 9.9.9.128 through 255. Which means if I use this /25, I'm accounting for these 626s, but additional IP space here that I didn't mean to summarize. And if I use this /25, I am accounting for these 2 /28s, but a lot of additional IP space that I didn't mean to summarize. So even though a /25 is the correct number of IP addresses, it doesn't fall on a boundary that matches exactly what I'm looking for. Which means if I want to summarize these 8/28s into a single network, I would have to go all the way to the /24. This /24 definitely includes all of the IP address space that I meant to summarize. Of course, it also includes additional IP address space that I did not mean to summarize, but that is the offset or the risk you get if you must summarize to a single network. If I wanted to summarize these to exact match, I could take these /28s and summarize them into this 27. I could take these 4 /28s and summarize them into that 26. And then I could take these remaining 2 /28s and summarize them into that /27, giving me an exact match answer of those 3 subnets. These 3 are the exact match summaries of these 8/28s. And this 1 is the single network summary of these 8/28s. Cool. So those are the 3 examples that I wanted to work through together before I essentially give you a quiz and see if you can figure out the single network and exact match summary yourself. Again, I want to turn it to the chat room. How is all this going? Is this all making sense? Let me know if this is all good. Throw some emojis in there, or let me know things make sense. And if so, I'll turn it over to the next slide, which is going to be a quiz, which will introduce rather the quiz that you guys are about to do to see if you guys can do this on your own. Cool. Glad this is all making sense. Okay. So let's do it. So now it's your turn. I'm going to give you 3 different illustrations. And for each of them, you're going to essentially give me 2 answers. You're going to summarize everything into a single network. And you're going to summarize everything into as few networks as possible. So this is essentially going to be your chance to see if you've learned what I've communicated so far. Now on the next slide, I don't have a copy of this cheat sheet handy, so if you want to use it, feel free to take a quick screenshot or jot it down real quick, because it's not going to be it's not going to be available to you on the next slide. That said, here are your problem sets. So again, for each of these 3 problems, you're going to solve 2 things. So I'm going to expect 6 answers from all of you. Summarize for the first one, for problem A, summarize these 8/28s into one network or as few networks as possible. For problem B, summarize these these 8/28s that are not sequential into one network or as few networks as possible. And finally, for problem C, it's going to be those 4/28s right there. I'm going to go ahead and mute out my mic, and we're going to start a 5-minute timer. And yeah, in 5 minutes, we'll work through the answers together and see how you guys did. If you guys have any questions for me on what you're supposed to be doing, feel free to pop into the chat. Otherwise, let me get a 5-minute timer started. All right, we have about 10 seconds left or so, and then let's start working through these together. Okay, cool. So let's do this. Starting with the first one. Okay, cool. So for this first one, here were the 8/28s that we needed to summarize. Cool, I'm seeing some of the answers pop into chat. Fantastic. So for this first one, 8/28 again does include 128 IP addresses, which could fit in a /25. But we don't have a /25 that fits in the right block to account for these 8/28s. There isn't a /25 that starts here and ends here, right? 25s have to start in increments of 128, so it's always going to be .0 or .128, which means if we were trying to summarize these into a single network, our only option was that /24. So the answer for that first one would be 999.0/24. Now to solve for an exact, oops, that's what should be exact match. Exact match. We could take these /28s and summarize them into this 26, and these /28s and summarize them into that /26. A /26 has an increment, if you look at the cheat sheet, has an increment of 64. So this one is .0, this one is .64, this one is .128, and those are going to be our answers. 64/26. And, oops, 128/26. So those are the answers for problem A. So for B, if we were trying to match everything to a single network, we can't use /25s because we are in two different /25s, which means we have to then resort to the /24. So the answer for the first, for problem B, for a single network is also 999.0/24. And then for exact match, we could take these /28s, summarize them into that /27, these 28s and summarize them into that /26, this one rather, and then these 28s and summarize them into that /27. The increment for /27 is 32, so that's .0, that's .32, that's our first one. The increment for /26 is 64. So again, we've got 0, 64, 128. And then, so that was 128. This would be 192, which is kind of where we start here. 192 plus 32 would get us 224. That is where that /27 starts. So the answers for that guy would be that right there. So that is the exact match for problem B. And finally, C, the most tricky of the set. This /28 actually can't be summarized because the 27 would be too much. This 28 also can't be summarized because the /27 is too much. Same thing here and same thing here. So if we were trying to summarize as exact match, I actually cannot summarize these any smaller than they are. So the answer to summarize these by exact match would be still the 4 /28s in the original problem set. If I was trying to summarize them into a single network, that /25 encompasses them all. So my answers for that one would be, single network would be 999.0/25. And then the exact match would be the actual, each of these /28s in the original prom set. So /28 has an increment of 16. So that first guy is 999.16. Next guy would be 32. Whoa. Then we would have, do some math, so that's 32. This guy would be 48. This guy would be 64. And then finally, the last one would be, so that's 64. That guy would be 96, and this guy would be 112. Cool, welcome, Zolifikar. I don't know if I'm saying your name right, but cool. So that is us solving a few more of these together. But here's the thing. When we're trying to solve these using these cool visualizations, it's actually not too difficult of a thing to solve, right? We just got to see where everything fits into the closest, biggest network to the left. But in an exam or in the real world, you're not always going to have time to draw out that entire table. So what we're going to do next is show you how to solve these by hand. Now, I do want to mention that solving for exact match by hand is actually pretty rare. Generally, if you're trying to be that specific, you're going to want to throw it into some sort of subnetting calculator to do the work for you, to make sure you're not leaving things to human error or anything like that. Plus, solving for exact match isn't really something you can shortcut your way through. It's just a measure of being very familiar with subnetting, calculating network ID and following broadcasts and next network and continuing that through to see if everything can fit into smaller and smaller subnets. Instead, much more often when you're doing supernetting or aggregation problems, you're trying to summarize everything to a single network, especially at the CCNA level. So if you're at the CCNA level, you don't need to worry about this too much. Generally, if you're being asked to supernet or to aggregate networks, it's going to be to a single network. And this is actually very, very easy to do quickly and accurately. I'm going to show you. Now again, the prerequisite for this was having seen the Subnetting Mastery video series. In that series, I showed you how to solve quickly for these 7 attributes right here. You'll see that, rather, in that series, I told you that every subnetting question you ever encounter is just going to be asking you to solve for one or more of those 7 attributes. Well, in this case, when you're doing supernetting, the subnetting attributes you care about are the network ID and the broadcast IP. Let me show you. So here is the process for solving supernetting problems with scratch paper. You're going to see we're not going to use any table other than, of course, our subnetting chart that was in the Subnetting Mastery playlist. You're going to see that the process is just a 2-step process. I'm going to show you. So we're going to start with this set of 6 /28s. Now these should look somewhat familiar to you. We did this visually, but I want to start here just so that we can take a baby step into understanding how this all works. To solve supernetting problems with scratch paper only, there's only 2 steps you have to take. The first step is identify the smallest IP address and the largest IP address. Now when you're giving subnets, understand what that means is this is going to be the network ID of the lowest numerically subnet, and this is going to be the broadcast IP of the highest numerical subnet. That's how we will get our lowest IP address and our highest IP address. So over here, our lowest IP address is going to be the network ID of that network, and our largest IP address is going to be the broadcast IP address of that network. So if we did some quick math, the network ID of that guy right there is obviously going to be 9.9.9.0. That one's pretty easy. And the broadcast IP address of that guy right there, a /28, gives us an increment of /16. So if we add 16 to this network ID, we would get 112 plus 16, that is 128. And then and that 128 is actually the next network. So to solve for broadcast, you would subtract by 1. which means that the broadcast IP address of that guy would be 9.9.9.127. From here, you don't even need to look at anything happening in the middle, because the next step is simply to figure out a particular group size increment, which includes both of these addresses. That's it. You don't have to do anything with all these IP addresses in the middle, because if you find something that includes the smallest IP address and the largest IP address, it definitely also includes everything else in the middle. So in this particular case, .0 and .127, if you subtract these out, 127 minus 0, that gets you 127, which means that's going to be too small, that's 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 too small, which brings us to /25. Now we just need to see if there's a particular jump, /25 jump, that we can use that incorporates both of these addresses. Well, as you know, 125/25 rather has an increment of 128, which means all the network IDs start with .0 and end with 128. And you'll see that both of those fall into the first /25, giving us an answer, a summary answer of 9.9.9.0/25. Okay, so that's the first one that we're going to do. We actually have 5 more examples that we're going to work through together. But you'll see, in each case, it's still just a 2-step process. Find the smallest IP, find the largest IP, and find a group size increment which includes both. All right. The next one we're going to work through is this guy right here. So now we only have 4/28s that we're going to work through, and we're going to summarize those. But again, the process is the same. Find the smallest IP, find the largest IP, and figure out a group size increment, which includes both. So for us, in this one, the smallest IP address is going to be the network ID of that subnet, and the largest IP address is going to be the network ID of that segment. So the network ID of that first one, the smallest IP address, is going to be 9.9.9.64. And then the broadcast IP of that guy, it's the same subnet as before, so we can actually just reuse it, 999.127. Now I just need to find a particular jump that includes .64 through .127. If you subtract this out, 127 minus 64, that will get you 63, which should get you to jump right to the /26, because all of these are going to be too small. And then if you do the network IDs for /26, you'd end up with .0, .64, .128, .224. These both fit in this network right here, giving you an answer of 9.9.9/26. So this would be your answer to the summary problem to summarize those 4/28s into a single network. We're about to work through a few more. Real quick, I want to turn it over to chat, see how things are going. I'm going to show you the next problem, but go and tell me in chat, let me know if everything is settling okay, if this is all making sense. With that said, the next problem we're going to work through is going to be this guy. Now this guy, if you'll notice, we're given different sized networks, right? That's totally fine, and probably something that'll occur in the real world or on certification exams. But in all cases, it's still this simple 2-step process. We're going to find the smallest IP address, and then we're going to find the largest IP address and figure out a group size increment that includes both. So for this particular example, looks like our smallest IP address is going to be this guy right here, which means we are going to start at 9.9.9.128. And then the largest IP address will be the broadcast IP address of that subnet right there, slash 29 is an increment of 8. So if we add 8 to this guy, 240, we would get 248. That's the next network. To solve for the broadcast, we do -1, which means that the largest IP address, or the broadcast IP address of this slash 29, is going to be 9.9.9.247. And again, now we just need to find an increment that fits that jump right there. Now if we did 64, 128 plus 64 gets you 192. That's going to be not big enough to include all of those. If we went one size up to 128, 128 plus 128 would get you 256, but obviously it'd be a .0 and increment the next octet. But it does indeed include both the largest and the smallest IP address, which means that is going to be the answer. So the answer to this guy would be 999.128/25. That would include all of those 4 different size subnets. Again, the process is always the same. I'm just following these 2 steps. Cool. So far, we've been doing problems that involve subnets. But we can also do problems that involve individual IP addresses. The process still doesn't change. No matter what, we're still just going to find the smallest IP and the largest IP and figure out a group size increment that fits both. In this case, it looks like these are sequential, so our smallest IP address is going to be .130, actually let's do the arrow, .130. Our largest IP address is going to be .160. If we subtract those from each other, we get a jump of 30. Instantly, that tells me all of these are going to be too small. Let's see if we can find a group size increment of /27 that includes all of these. So we would have, also, if you saw the Subnetting Mastery video series, video 5 talked about speed tips that let you jump to things more efficiently. One of those speed tips is that you can always start at .128. I think that's speed tip number 2, I believe. Either way. So 128 plus 32 would get us 160. And you'll notice all, six of those IP addresses fit in this range, which means the answer to summarize these into a single network is going to be 9.9.9.128/27. Oh, I did not mean to erase that so quick, but either way, it's on YouTube, so you can always just back up and see the answer again. Cool. So hopefully now you understand, and you can see how it's really just a 2-step process to solve supernetting problems. But so far, all the examples we've provided so far have been in the 4th octet. Well, what if we had a problem that involved us supernetting in the 3rd octet? Here we have, 8 different IP addresses, but you'll notice we have changes in the 3rd octet as well as the 4th octet. Well, you can still use this exact same 2-step process to supernet these very easily. And again, not again. Of course, since we are now in the 3rd octet, we are going to have to extend our cheat sheet to also include 3rd octet. And again, I give you details on how to do this in the Subnetting Mastery video series. I believe it's video 6, where I show you how to extend the cheat sheet to include 3rd octet. But you'll see that the process is still exactly the same. So let's see if we can find the smallest IP and the largest IP. So if we're looking at this list in here, the smallest IP address looks like it's going to be this guy. Unless I'm missing something, please point it out in the chat if so. And the largest IP address numerically is going to be 43, the guy right above it. That guy. So if we write those out, we've got 9.9.41.24 as our smallest IP, and 9.9.43. Let's make that a little bit neater. 43 209. Cool. Now, here's the thing. Notice the instruction said the relevant octet. Well, in this case, since changes are happening in the third octet, that is actually my relevant octet. So I need to find an increment that includes both 41 and 43. Now, I have to be careful here because if we subtract these out, that gets us a jump of 2, right? So we could possibly use a /23, but I don't want something that goes 41.0 to 43.0. Notice this is 41 dot something to 43 dot something. So I can't just jump an increment of 2 right there, because that's not going to be enough to include the additional IP addresses on the fourth octet. Therefore, this is actually going to be too small, which means the next increment I'm going to look for is .4. Sorry, jump of 4. I shouldn't say .4. In any case, if you use the Subnetting Mastery speed tips, we know that if we're doing an increment of .4, one of the speed tips just has you multiply the increment by 10. That gets you right to .40. And if I add 4 to .40, that gives me to 44. And that right there already encompasses the octet change that I was trying to account for, because 41 through 43 is going to fit in this range right here, which means my answer is going to be 9.9.40.0/22. This summary is going to account for the largest and smallest IP address, and therefore all 8 of these individual IP addresses that I was trying to summarize. Finally, we have one more example we're going to do together. That example is also going to be the third octet, but it's going to include subnets. Whereas in the past, the problem prior was individual IP addresses. Now we're going to do one more that involves subnets. But you'll see that the problem, again, is the exact same. The solution is the exact same steps. We're going to find the smallest IP and find the largest IP. So let's start with the smallest. So the smallest IP address on this list, if I'm looking at it correctly, is going to be that 23 right there. Let's write that out. 99162.0. And then the largest IP address, if I'm doing the math, is going to be that guy right there. Yep, not missing anything. But we need to find the broadcast IP address. This is a /28. So a /28 is right here. So we have the increment of 16. And again, since it's a /28, we're in the fourth octet, which means which means the next network is going to be 224 plus 16, which gets us to 240, which means the broadcast IP address is going to be .239. So 99173. 3.239. That's supposed to be a 9. Okay, cool. So again, we have to find the largest IP address, not the largest subnet. Keep that in mind. So now we just need to find a group size increment in the relevant octet, which in this case for us is going to be the third octet, which includes both of these addresses. So that's 162. Cool. So if you do 173 minus 162, that's a jump of 11. So instantly that tells us all of these are too small. Let's see if we can find a jump of 16 in the third octet that includes both of those addresses. And if we use the same cheat sheet, the speed tip, where we just multiply the increment by 10, that'll get us to 160, because the increment is 16. And then the next increment would be 160 plus 16, which is 176. And you'll see this definitely includes the 2 addresses that we were trying to account for, which means my answer is going to be 192.9.160.0/20. And just like that, we were able to solve yet another problem, summarization problem, using this two-step process. And that actually wraps up everything I meant to do together. So, if you've sat through this live stream, then at this point, I'd like to think that you're pretty confident and pretty capable at solving supernetting problems going forward using this two-step process. Before I cut everybody loose, I do want to turn it over to chat to see if there's any questions. So while I'm cleaning this up, go ahead and pop something into the chat room. Let me know if this is all sitting well, or if you have any questions, or if this all makes sense, or if you feel like you could take on some supernetting problems going forward. Not seeing any questions in chat, which tells me that we must be feeling pretty good. Here we go. Thank you, Michael. Michael said, thank you. Absolutely, you're welcome. I'm glad this was useful for you. So what we did today is we defined supernetting and aggregating. We illustrated how to solve those problems using the visual representation. Then we did a quick quiz, and then I showed you how to do it again using only scratch paper. And that is actually all I had for you today. If you have any additional questions for me, please find me on this Discord. This is my blog YouTube channel's Discord, so feel free to pop in, say hello, see what other people have been watching, what other people have been reading, or ask questions if you have any follow-up questions. I'm in the Discord pretty often, as well as a few other, we'll call them experts, that are there happy to help if you have any questions about anything. Otherwise, that is all I had for you guys. We will go back to that right there. I hope you guys enjoyed this live stream. Hopefully it kind of solved, answered some questions about how supernetting works for you. As with many things in the networking engineering industry, a lot of the stuff seems very complicated until it's broken down in the right way. And then it all clicks. And at that point, you're almost like, oh, it was actually kind of obvious that it worked that way. Hopefully this session was able to communicate that to you. Yeah, and otherwise I've got nothing else for you guys. Hopefully you guys enjoyed that. I'll probably be doing more live streams in the next few weeks, months, years, whatever. If you guys enjoy it, definitely make sure you interact with the video, comments, thumbs up, all that fun stuff. That helps the YouTube algorithm show me love, if you will, which will help the channel grow. And the more it grows, the more I can dedicate time to creating this type of content for you guys. If you guys have anything else you want me to cover, definitely let me know. Definitely hit me up in Discord, hit me up in YouTube comments or something like that. I'd be happy to create content that would make the most sense for you all. Otherwise, thank you for joining me. Have a wonderful rest of your Saturday. Enjoy whatever it is you are learning or doing today, and we will catch you next time. You guys are very welcome. You're welcome, Carlos. Absolutely, Steven. The cool thing about YouTube is that the live stream is here for you guys to review if you guys want. Absolutely, Michael. Glad you enjoyed it. Cool. Well, that's it. I'm going to kill the stream. If you guys have any additional questions for me, hit me up on Discord. Otherwise, thank you for joining, and we will catch you next time.